Hey everybody, in this video we're going to be taking a look at the order of operations. And I think the best way to do that is to go through a few different examples and we'll actually get some practice using the order of operations. Now, depending upon the order in which you do things within an expression could have profound impacts on the final result of that expression. So we need to have an agreed upon way to go about solving or simplifying problems in order to do them consistently. So to do that we have the order of operations. So you may have heard of the acronym PEMDAS here, P-E-M-D-A-S. I think in different parts of the world they may have a different acronym, but this could stand for, if you need to remember this, you could say, "Please excuse my dear Aunt Sally." I think that's how the saying goes here. But what that stands for is the order in which we should do mathematics when it's written down. So we see that parentheses should come first, followed by exponentiation, and that's followed by multiplication and division. Now, multiplication and division could actually be interchanged. It doesn't matter which one of these will go first here. And then after division and multiplication, we move on to addition and subtraction. And these two are also interchangeable as well. So this is the order of operations here. So let's go ahead and put this into practice by beginning with number 1 here. And by the way, you could click on any of these problems here to go straight to that problem. So moving on, let's have example 1 here. So for example 1, we have 3 times 6 plus 16 over 2. Now, according to order of operations, we see that parentheses should go first. But in this case, we don't see any sets of parentheses. Now keep in mind though, you may not see parentheses. Sometimes they're actually invisible. And in the case of some fractions and square roots, that may certainly be the case. And there is an explanation as to why those are kind of invisible sets of parentheses. But we'll have to be wary of those too if there are any. Next up, are there any exponents? No, not in this problem here. Next up, is there multiplication or division? And yeah, in this case we have 3 times 6. So we're going to go ahead and do that. Oh, by the way, these are all expressions. I have the directions written out here. We're trying to simplify these expressions. So there's no solving of equations here. It's just taking this complicated looking expression and making it look a little bit easier. And of course there's plenty of advantages to that. Whenever you write down a number, you don't necessarily want to write down a long expression like this. So if these expressions arise somewhere, we'll be able to simplify them. So that's the directions here, simplify. So now we got onto multiplication. We have 3 times 6, which is 18. Now we have addition. We're not going to do the addition yet. We're just going to write it down. And then 16 divided by 2, well, that's 8. Okay. So this is equal to this. That's fine. Next up, we finished all that. Is there addition or subtraction now? And yeah, 18 plus 8, that's addition. That's equal to 26. Okay, so that's one example. Moving on to example number 2. This one's a bit trickier. Write down 2. We have 9 minus 6 times 4, and all of this is being squared. Okay, so in this problem, we want to simplify this one here. We have this whole quantity being squared. So let's go through this list of order of operations here. We have parentheses to begin. Do we have any set of parentheses? Yeah. Okay. Now, if we do have a set of parentheses, we're going to work within those parentheses, following the order of operations still within that set of parentheses. Okay, so now we're within the parentheses, and we need to follow the order of operations within that set of parentheses. So, are there parentheses within that set of parentheses? And no, there's not. Are there exponents inside of those parentheses? No. How about multiplication? Yep, there certainly is. So we're going to go ahead and carry that out. We have 9 minus, now 6 times 4 is 24. And this is all still being squared. Okay, is there any other multiplication or division within this set of parentheses? And no, there's not. So next up, is there addition or subtraction? And yeah, there's subtraction. We have 9 minus 24. That's going to equal negative 15, right? Yeah, negative 15. Okay, and that is all being squared still. Okay. Now that looks to be about it inside the parentheses. We can't do anything else. So we move on back to the top of the list. We're done with the inside of the parentheses. What's next? Well, if there's any exponents, we have to make sure we carry out the exponentiation. So here we have negative 15 squared. So think about what squaring something means. That's negative 15 times itself. Right? Negative 15 times negative 15. And that's equal to, well, we have a negative times a negative, so that's going to be a positive. And 15 times 15 is 200 and, no, is it? Oh, yeah, it's 225. Yep, okay, so 225. Okay, and that's it for that expression. Once we get this final number, there's certainly nothing else we could do with that. So that's number 2. Let's go ahead and take a look at number 3. Okay, so this one's a bit tricky. This is something you're going to have to watch out for in future examples. This is a big stumbling block for quite a bit of students, so be careful you don't fall into the trap that's contained in this problem here. So number 3, do we have any sets of parentheses? Yeah, we do. We have this set of parentheses over here, but is there anything you could do inside that set of parentheses? And in this case, no, there's not. Next up, do we have exponents we need to deal with? Is there exponentiation within this problem? And yeah, there certainly is. We have this 2 to the 4th and this negative 3 to the 4th. Now notice how I said we have 2 to the 4th. We don't have negative 2 to the 4th. It's just 2 to the 4th. Okay? Because this negative is really a multiplication. This is a negative 1 essentially times 2. And we'll see that the multiplication here, or if you want to think about it as a distribution of this negative, comes after exponentiation. So in this problem, we have a negative sign sitting here, but we need to carry out the exponentiation first. So 2 to the 4th power is 16. Okay, and that negative is still sitting there. So we did 2 times 2 times 2 times 2 to get 16, and the negative here remains. Okay, that was not part of the exponentiation. Okay, that's different from this situation over here. We have negative 3. All of this, instead of the parentheses, is raised to the 4th power. So over here, we do have negative 3 times negative 3 times negative 3 times negative 3. And if you do that out, we should get a positive 81 here. Okay, so there's a big difference. If this was negative 2 times negative 2 times negative 2 times negative 2, we would have gotten a positive 16. But again, this distribution of the negative, or this factor of a negative 1 sitting here, is technically, you could say that it's a multiplication. So again, that's coming after the exponentiation. So that's why we're obtaining this negative 16 here. We do 2 to the 4th first, and then negate it. And now, once we get this here, we have negative 16 plus 81, so we should get 65. Okay, so that is number 3. Again, be very careful of this trap. It's easy to fall in the mistake of thinking this is negative 2 to the 4th when really it's just 2 to the 4th. If I had this, then it's negative 2 to the 4th, and we would obtain the positive 16. But again, that's not what we had. So let's move on to number 4. So in number 4, we have the square root of 25 plus 3. And this is all being divided by 4 plus 2. Okay, so we need to simplify this using the order of operations. So in this case here, number 4, when you look for parentheses, now it doesn't look like there's parentheses, right? But in this case, we do have invisible sets of parentheses. Whenever we're dealing with a fraction here where there's multiple sets of operations on the top and on the bottom here, you do want to think about the numerator as being in its own set of parentheses, and the denominator as well being in its own set of parentheses. Okay, so we want to work in the numerator and in the denominator as much as we can first, and then we'll go ahead and divide once it's simple enough. So are there parentheses? It's an invisible set, yeah. So let's work within the numerator here. We have the square root of 25, right? And square roots actually counts as exponentiation here, because square roots could really be turned into fractional powers, which we haven't talked about that yet. So, but when we take the square root of 25 here, we get 5. It's a 5, positive 5 or a negative 5, but let's just take the positive root for now. And then we have a plus 3. And in the denominator, we have a 4 plus 2. Okay, so let's keep going with about what I said. Let's keep working within the numerator as much as we can, and then the denominator as much as we can. So 5 plus 3 in the numerator, we have 8. And in the denominator, 4 plus 2, we have 6. And if we simplify 8 over 6, we see 2 is going to go into both 8 and 6. So this reduces to 4 divided by 3. Okay, so whenever we're dealing with a fraction like this, again, keep in mind that you want to work in the numerator and in the denominator as much as you can first, and then lastly divide here. Now moving on to the last example here, we have example number 5. So there's a lot of things going on in example number 5. We have negative 3. Well, really, again, remember this is negative, and then 3 squared, then times 4 plus 8, all divided by the square root of 45 minus 9 and minus 3. Okay, so parentheses. Now, there's the invisible set. Again, we want to work within the numerator and in the denominator. Now, there's actually another invisible set here, and that is within a square root here, this 45 minus 9. Whenever you're dealing with a square root like this that has the operations, some operations going on inside of it, that also has its own set of invisible parentheses. So you're going to want to cover this before you cover most other things. So let's work within the numerator here. Now this is going to be negative. When we do 3 squared, we get 9. And then this is times 4 plus 8. And this is being divided by. Now we have the square root. So now we could go ahead and take a look within the square root what's happening. We have a 45 minus 9, so that gives us square root of 36. and there's a minus 3 here. Okay, so then up top, we're going to be dealing with some multiplication. So we have negative 9 times 4. That gives us negative 36. Then we have a plus 8. And this is being divided by. Now the square root of 36 is either 6 or negative 6. But let's just work within the with the positive root here. Let's just take positive 6 and minus 3. Okay. So now up in the numerator, we're just dealing with addition now. So negative 36 plus 8, we get negative 28. And this is divided by 6 minus 3 on bottom, that's 3. Okay. And this doesn't simplify any further. If you wanted to know if a number was divisible by 3, you could actually add up the digits of the number. Here we have 2 and 8 that adds up to 10. And if that number, if the sum is actually divisible by 3, then the number itself is divisible by 3. Like take 27 for instance. If you have a 2 and a 7, they add up to 9. 9 is divisible by 3. The number 27 is also divisible by 3. That works with the numbers 3, and that also works with the number 9 if you wanted to know if something was divisible by 9. But you could come up with tricks for other numbers as well. But 3 is an easy one to do. The other numbers, the tricks for finding out if something is divisible by other numbers, it's not so easy, but 3 and 9 are easy to do. Okay, so that was a look at a few examples for order of operations. Give these a try again or click on any one that you might not have understood. And I'll see you in the next video.